Hello guys, so today we'll be creating a very basic, a simple fast API application which will have a simple like one model, user model, and we'll be creating CRUD APIs around it, and later on we'll be dockerizing it. So yeah, let's get started. So the first thing is I'll be creating a virtual environment. So yeah, so as you can see, virtual environment is created, so we can activate it using source, and then we bin activate. So yeah, virtual environment is activated. So in this virtual environment you can see what packages are currently installed using pip freeze. So as you can see, we don't have any package installed. So for this fast API application, we'll be needing a couple of packages like fast API, to work with, like to create a application, our application. Then we'll be needing SQL Alchemy, which is basically used as ORM to connect with database. Alongside, we'll be needing a driver called psychops to binary, and yeah, so we can install them using pip install fast API. Then we will need SQL Alchemy psychops to binary, and yeah, we'll also need another package called pydantic settings. So this package is basically used to read the environment variables from .env file. So yeah, let's install these packages. Okay, you can see packages are installed, so you can check the list of packages installed using pip freeze. Yeah, so we have installed fast API. You can check it here. We have fast API, then we have like SQL Alchemy, then psychops to binary, and pydantic settings will be, yeah, this is pydantic settings. Okay, so let's grab these versions of these packages into a requirements.txt file. So pip, you can hit the command pip freeze requirements.txt. So this will list down all the packages that are needed. So in future, if let's say you want to, or if somebody else want to install the dependencies needed to run your project, so they can simply run this command pip install -r requirement.txt, and all the packages will be installed. Yeah, okay, cool. So okay, we'll be creating a folder called app, which will contain our fast API application, and inside this, let's create a simple main.py file. So main.py, okay, cool. And let's also make this as a package by creating any.py file. Okay, so yeah, inside our main.py we from fast API we import fast API, and we can create our application using fast API from this class fast API. Okay, and yeah, so you can do app.get okay, so this is our very basic fast API application. So let's try to run it. Okay, so fast API, so as we got an update in fast API, so fast API CLI is introduced, so we can run our application using fast API app.main fast API, I guess it's fast API dev app.main. Okay, okay, sorry, I'm back. we have to give path of our main file. So yeah, our server is running on localhost 8000 port, so we can check localhost 8000. So yeah, you can see we got response, hello world. Cool. Okay, now let's modularize our application. So let's create a couple of folders. So for routing, we'll create a folder called router. We'll make it as a package by initializing init.py file. Then alongside we'll need models, so where we'll be creating our models. .py. Okay, and we'll also need views. You can also call it as route functions. So views, and then what we'll need, we also need serializers, right? So let's create a folder for that as well. Serializers. Okay, cool. Let me close all the tabs. Okay, cool. So let's first create a router. So okay, sorry, let's first create a model. Let's call it as user.py. Okay, so let's create a model, user model. We'll get to this base in a moment. So yeah, we have table name, users, then we'll be having a couple of columns like user ID, the name. Let's get email of user, like let's say phone number, and is active. Okay, we'll need to import from SQL Alchemy, import column and also integer, string, column, integer, primary key, name, column. This will be string, email, this will also be a string, phone number, let's keep it as string as of now for simplicity, and is active will be a boolean which will default to true, and we'll need to also import boolean. Okay, cool. So we've created our model. Okay, now let's create a file which will handle database related stuff, so database connection and session, all the related stuff. So for that, let's create a folder called config. Okay, and let's create a file called database.py. Cool. So here we will first need to create an engine. So from SQL Alchemy we can import create engine, and then we can write a create engine, and here we need to pass database URL. Okay, so database URL. So this is the format of database URL string. So we first have like what is the driver, then username, password, host. Here we have port, and we have database name. So let's name our database as FastAPI testDB, something like that. Okay, so my username is Postgres, password is admin, localhost 5432. Cool. Yeah, so we've created our engine. So we'll also need to create session. Okay, so from sqlalchemy.orm, let's import session maker. Yeah, and let's call it as session local session maker. So here auto, let's set few parameters like auto commit false, auto flush false, and bind equals to engine. Correct. Okay, after that let's create a base which will be used as a base for all the models that we'll be creating. So from sqlalchemy.ext.declarative import declarative base, and let's create a base down here, base equals to declarative base. Cool. Okay, and let's write a function to get the session. So like get db, like that, db equal to session local try yield db finally db.close. Okay, cool. So yeah, we've created our file which will have our engine which will be used to interact with database. We have created a session and a base. So let's import this base. So from app.config.database import base. So yeah, this will resort to base. Now let's create a route. Let's call it as user.py. Okay, okay, so we can import from FastAPI import API router, and let's create a user router, API router. So let's give a prefix as users and tags as user. So this tag will be treated as all the routes that will define under this user router. So they all will be grouped inside the documentation that is automatically created by FastAPI. Here let's define routes like user router dot add API route path as. So we'll need like a couple of routes for CRUD API. So let's say endpoint equal to, so we'll need, let's create for create user methods, this will take as post. So let me copy, this is for create, then we'll create one more route for listing the user. So let's call it as list user, and the method will be get. Correct. And then let's create one more route to retrieve user. So the path will be /users. So this prefix that we have defined here, so this will be used as a parent prefix, we can say. So all these routes will be accessed by using /users and then this path. So for retrieving user, we will have a user ID. Correct. And let's call it as retrieve user. Method will be get again, and let's create one for updating the user, update user, and let's create one for deleting the user. So the method will be put and delete. Okay, cool. So these functions will need to define in views. So let's go to views and let's create user.py. Okay, let's go to views and cool. So yeah, here let's create route for let's say creating user. So create user. Now in order to interact with database, we need to grab the session that we have created, right? So what we can do is we need to first import from FastAPI import depends, and here we have created this where is it? Yeah, in the database.py file we have created this function to get the session, so we can simply import it like from app.config.database import getDB, and yeah, we can say db. So let's import session. So from sqlalchemy.orm import session. So this variable of type, the variable db will be of type session, and it will depends on getDB function. So what this says is that, so whenever control will come to this route, so first this function will be like we have defined this dependency, right? So first this dependency will be resolved, so a call will be made to getDB function, and it will return the result, and then the control will go inside the create route create user function. So yeah, we've got the db session handler over here, and for creating user we'll get payload right from the request. So let's get that payload in user variable, and let's say as of now we haven't created serializer, right? So let's say we will create a serializer. Okay, let's first create a serializer. Then let's go to serializers, user.py. Cool. So let's go to serializer and let's go to users.py, and yeah, so class user base. So we first need to import from I guess it's from pydentic import base model. So yeah, inherit from base model, and what we have like name in our model, so it was of type string. Then we had email of type string, then phone number of type string, then is active, it was of type boolean. So this is a base serializer, you can say, we have created, and we can use this base serializer to create multiple serializers for retrieving the user, for creating user, updating, whatever. So let's create a class for retrieve. Sorry, we need it for create user serializer. Let's inherit from user base, and we have all the fields inside user base, so we don't need to add any field over here, right? So let's create serializers for other as well. So we have retrieve, we'll be needing retrieve user serializer. So here we'll need one extra field which will be id of that user created, right? Okay, cool. After that we'll need one for list user serializer. So we'll inherit from base model, and over here we'll have users, and we'll have list of retrieve user serializer. So every item of list user will be an instance of retrieve user serializer. So we'll add it over here, and from typing we need to import list. Okay, cool. And yeah, I forgot to add one more thing. So here we need to add class config from attributes as true. So we'll copy this and add it over here. So what this does is basically we can simply pass the ORM object into the serializer, and it will automatically serialize it, so we don't need to do any extra work if after adding this. So yeah, we've created a serializer. So let's go to view where we needed serializer. So from app.serializer.user import create user, then we add retrieve user and list user. Cool. And yeah, while creating user we will be getting a payload, so we need to validate the payload. So we can create a variable to get the payload, and we define that variable as a type create user serializer. So FastAPI automatically validates the payload for us, and if there is some a field is missing or something, it throws error. So yeah, cool. So let's say write logic for creating user. So let's say user is equals to, let's first import the model from app.models.user import user. Okay, so let's use model dump for this. Cool. So like this we can create a new user, and let's using this database handler we can add it like db.add new user, db.commit, and we need to return it. So while returning we can use the retrieve user serializer, and we can simply use a method called model validate, and we can pass the ORM object, right? And this will automatically serialize it. So we can add one more validation over here. Let's say if somebody tries to use the same payload and create users multiple times, so we should throw an error saying that the user is already exist. So we can add a check for existing user. So we are querying the database on user model, and we filtering it by user.email. So we'll be having an email field in the payload, and based on email will be an unique identifier for user. So it's considered that way. And so we'll check if there is any user present in the database with this particular email ID, and if there is any user, then we should simply raise an error. So let's import HTTP exception from FastAPI. So we'll raise an exception where status code will be 400 and detail will be email already registered, or you can also say that user with email already exists. Cool. Okay, so we have created this create user. So let's create other methods as well. So list user, we got the session, we simply query on user and get all the users. And now here what we are doing is we're using list user serializer and model validate method, and we are passing all the users, but we need to pass them this way, like users and users. So why this way? Because in list user serializer we have said that we'll have one key here which is users, so this will map to this key, and every item in this key, so this will be a list, and every item will be a retrieve user serializer, so it will automatically serialize it. So this is for list user. Let's create for retrieve user. Okay, cool. So yeah, what we are doing is we'll get an ID from request, user ID. We'll get that in user ID, which will be of type integer, and we are getting our session, and we are querying in database with that particular user ID. So if we don't get any user, we'll throw an exception saying that with status code 404, which is user not found. And if we get any user from database, we will simply return the user. Let's create one for update user. Okay, so what we're doing over here is, in update user we'll get also the user ID, I mean the ID of the user which we want to update. Then we'll get few things in payload, like what we want to update. So here let's take it as a simple dictionary, and we have a session. Cool. So we'll first check if any user present. If there is no user present, we'll just throw exception. Then what we can do is let's just do this way. db.query, let's query the user. Okay, let's we don't, okay, never mind, we can do this way as well. So just update the data of existing user and comment it. Or I think the better way would be, let's do that way. db.query, query the user, filter using user.id equal to user id and update. Or we can simply say existing user dot update user data. Simple. Let's update the variable to user data, and this will update it, and this will commit the changes, and we can return the modified user from this. So now let's just create one for deleting user. Cool. Okay, so we'll again get ID. We'll check for existing user. If there is no user, you can say user not found, and simply you can delete the user and commit it. So yeah, we've created all the CRUD APIs, and we have we need to import those route functions or views. So from app.views.user import create user, list user, retrieve user, update user, delete user. Okay, cool. So let me just check once. We have created our main file. Okay, so now we have created this router, user router, right? So we have to import it inside our main.py. So yeah, inside our main.py we can simply say from app.router.user import user router and app.include router user. So this will include all the paths that we have created inside user router. Okay, cool. So we have created main.py, then we have created model. In here we have this user model, then we have created serializer for this model in serialize.py. Then we have created views for CRUD operations, and then we have created router which will handle all these requests and redirect them to the correct view function. Okay, one more thing what we can do is okay, so now we have created this, so let's move ahead. So let's Now we've created this, right? So we'll also need to create our database table, right? So we can use Alembic for that. So Alembic is a database you know migration management tool, we can say. So let's say you've created a project, you've created a couple of models, and you've created database from it. But let's say in future you want to update few like update few tables, like you want to update, add new columns or remove existing columns. So Alembic handles all these migrations, and it gets easier to handle the database changes. So let's firstly install Alembic. So pip install Alembic. Cool. So we've installed Alembic. Just give me a second. Yeah, let's add Alembic inside our requirements.txt. So yeah, let's check if we have Alembic over here. Okay, yeah, we have added Alembic. Cool. So let's use command to initialize Alembic init Alembic. Cool. Okay, so let's call this as migration. So let me delete this. We'll also need to delete this file as well. Let me just yeah, cool. Alembic init migration. So this will create a folder called migrations and one file called Alembic ini. So this will have all the configurations related to Alembic, and we have this migrations folder. So here you can see inside versions we'll have all the migrations that we'll be creating in future, and we have one file called env.py. So here we will have to make few tweaks in order to make Alembic realize that there are some changes have been made, or new tables have been created, or new columns have been added. So yeah, so let's do that. So here inside env.py we have this config, right? So we can do config dot set main option. Here we have to give the endpoint of our database, right? So we have inside our views, where do we have, I guess in database config here. So this is the this is the database connection string. So we have to update this variable. So this variable is defined in alembic.ini. So here if you SQL alchemy dot URL, yeah. So we have to update this variable. So what we have done is we have using this config dot set main option. So we are updating the value of this variable, and yeah, so we need to import our base. So we have defined from app.config.database import base. So this base will be used to provide the metadata, right? So here we need to update it with base. So all the metadata of all the models will be provided using this base, and yeah, we also need to import our models. So from app.config models dot user import user. So we have this one model user, and I guess that's pretty much it from the configuration point of view. So now let's create our migrations file. So we have this command called alembic revision. So it basically creates it is more or less like a git, right? So like we do git commit, right? So it creates a commit. So likewise, if we write alembic revision, it creates a migration file. So alembic revision auto generate -m, let's call it as created user model. Cool. So this what this auto generate flag does is it basically tracks the changes that we've made inside our models or in database automatically using this flag. And -m is this flag is used to provide a message like what we have done, right? What changes we have done. So this message will be used as a name of the file. So let's just hit this command. Okay, we've got some error over here. Let me just resolve it. I'll be right back. Okay, so what it is saying is the database does not exist. So let's first create the database inside our PgAdmin. Let me just start the PgAdmin. Okay, sorry. Yeah. Cool. Let's first create the database. What was the name of the database? Let me just check again. FastAPI test DB. Cool. So let's go to here. Let's go to servers, local. Cool. Let's just create a database called FastAPI DB, and let's keep the rest of the things as it is. Okay, and this will create a FastAPI test DB database. Now let's just go to our project and let's again hit the revision command. Okay, so I think I got some error. Let me see what I've done. Okay, imported models. I am done models. Okay, what we can do is I've got models import star, and inside here from dot user input star. Okay, and I guess yeah, so here we need to use base.metadata. Okay, so let's create a revision. Yeah, so if you can go to migrations versions, here you can see a file is created with the commit message or the revision message that we have added, created user model. So here you can see this is the structure of this migration file. So we have current revision number. So if we have any down revision, like let's say if we have first revision, and let's say if we create another revision on top of it, so this will link it as a down revision, so the linking will happen. So if we keep on creating revision, so it will link like what is the current revision and what is the previous revision. So likewise we have two functions, upgrade and downgrade. So upgrade will be all the commands will be, or all the instructions will be there to whatever the changes that we have made, those changes will be added inside upgrade. And inside downgrade will all the commands will be present, which are basically to undo the changes. So here we can see that we have created a table called users, and we have added this couple of columns, and inside downgrade we have drop table. So yeah, so now we have created our migration file. So let's simply hit the command to so now we have created our migration file. So let's update our database to have these changes. So for that we have command called alembic upgrade header. Cool. So it shows that it has created a model, so we can check inside our PgAdmin. So we can go to schemas, tables, and yeah, we have users table over here. So let's start user. So right now we don't have any data in it. So yeah, now we have migrated our changes. We have created a database. So let's do one thing. Let's just run our application. So what we have created so far. So FastAPI dev app main.py. Cool. So our application is running. So we can check it over here. Yeah, so this is running. So let's go to Postman and let's create a request. HTTP localhost 8000/users. So right, so this is a list users request. So let's hit it, and we don't have any users right as of now. So let's just create a simple user from PgAdmin. Let's name it as user1 user1.gmail.com, phone number and is active true. So now we have created a user. So let's go to Postman again and let's hit. So yeah, we got this response. So you can create all the requests for get, like all the CRUD operations. So I've already created all the requests. So let me just open it. So this is for list user, this is for create user, retrieve, delete, and update. Cool. So and I've created this environment variable. So you can click here in the environment section and inside local. So I've created this base URL. So its value is localhost 8000, and I can use it in all the requests. So I don't have to write it again and again. And let's say if our URL changes, so let's say for development you have particular endpoint, and for production we have different endpoint, or for any testing test bed, so you have different endpoints. So you can simply configure them inside the environment section, and here you can see let me just so we have we can select different environments from here. So let's say you've created a prod environment, test environment, so you can just simply click select the environment, and all the variables will be loaded accordingly. So here if I hover over this base URL variable, so I can see that this is the current value of it. So let's hit this. This is the list users request. So yeah, so let's create a user. So test user 2. So we have this name, email, phone number is active. This is the payload, and let's try to hit it. Let's see, this is the create user request, and it says that okay, status is 200, user is created. Let's again verify it using test user. So we have this 2 users. So now let's try to retrieve user using user ID. So we have users/user ID, right? So this is the retrieve request. We got the user. Let's try to update the user. Again, same endpoint, just method is changed to put, and inside body let's say we pass in name as test user 1, right? And let's try to hit it. So okay, there is some issue. Let's see what's the issue. Okay, it's saying that user does not have any attribute called update. So let's do one thing. Let's mm, so change this as like query and existing user equal to query dot first. So we can use this query over here. Cool. So now let's try again, and yeah, it did work. So let's verify it in list user. So yeah, we got test user 1, and let's try to delete user with id 2. Okay, it says 200. We can verify using list endpoint. Okay, so what if I try to delete user again, right? So it says user not found because we've already deleted that user. And let's see if I try to create user again. Yeah, so user is created because there is no user with test.user2@gmail.com. You can verify it, but let's see. Let's say I try to create it again, so it should throw 404. So yeah, it threw 404 and it says user with that email id already exists. So cool. So we have created a very basic FastAPI application. So one more thing I want to tell you guys. So as you can see inside app config, so we are taking this database URL, like we've given this static value. So a best practice is to read these values from environment, right? So let's say we have different environments for development, testing, production. So for all the environments, like the values might differ. So it's better to read it from environment file. So let me just create an environment file. So .env. Cool. So I've already created these variables. So let's just not take this, right? So db host, so our host will be localhost, port is 5432, db user is Postgres, password is admin, FastAPI, db what was our database name, FastAPI test db. So yeah, now let's create a file called settings.py. So we have installed this pydantic settings module, right? So this is basically used to read the values from environment file. So for that, let's go to, yeah, so for that let's create a class called settings, and it will inherit from pydantic settings. Let's import base setting, so we import from base setting, and we can simply provide the variable names that we've defined over here. So let me just copy this. Okay, and all of these are more or less string, just that db port should be, let's take it as integer, and let's give a default value to 5432. We have db host, we have db port, db user, password, name. Cool. And we have to provide like the file name from which these variables should be imported. So for that we have this thing called config, and here we can provide env file equals to .env. Cool. So what this will do is this will find .env file, and it will take the it will try to find this variable inside this .env file, and it will replace the values from it. So yeah, and let me also add one more thing. So from func tools import lru cache, and let's create lru cache get settings, Cool. So what this will do is basically for every request, let's say for first request, it will evaluate these values and replace the values in this variables, and for subsequent uh, initializations or API calls, it will directly get these values from uh, this cache. So it is like one time, so one time it will be evaluated and it will be cached, and then it will be read from there. So yeah, now here inside our database, I guess we'll have to change it. So this will like from app.config.settings, you can say import get settings. We can initialize it using get settings, and this is, let's create an f string. So this is the username, so it goes like settings.dbuser. Cool. This is password, so it goes settings.db password. This is host, settings.db host, settings.db port, and settings dot I guess we haven't defined database. Okay, we have given db name. Okay, we do have it, db name. So cool. And let's do, yeah, so this will be replaced, I mean these values will be evaluated runtime. And we also should change this inside env.py. So let's go to env.py. Okay, and here let's import from app.config.settings, import get settings. Settings is equal to get settings, and let's just copy it from here to the f string that we have created, and let's just paste it. Cool. Okay, let's do one thing. Let's put it inside, let's say database URI. You can use it over here. Cool. Let's say there is one more thing I would like to add. Let's say if you have any special characters inside password, so it actually doesn't work directly, so like @ or some other symbol. So what we can do for that is you can use data dburi.replace, and we simply replace it using this. So this will escape those characters. So yeah, now let's again try to rerun, and let's see if it is working or not. So let's just do this, and yeah, it did work. So cool. So now we have created our basic FastAPI application. So the next part will be Dockerizing it. So let's move towards it. So yeah. So for that the prerequisite is you need to install Docker. So you can just go here and you can install it for Linux, Mac or Windows. So I've installed Docker in my Mac, and I've also installed Docker desktop. So this is kind of a GUI for Docker. So here you can see we have different sections for containers, images, volumes and stuff. So I have a couple of images over here. Right, so once you have Docker installed on your machine, so what we can do is let's create a Docker file in our project. So let's call it Docker file. Cool. So Right, so let's create now let's in order to run our application, we have two different services, right? One is our fast API application, and second is our backend, I mean the database itself. So in Docker in Docker Hub, we have a couple of images for like Postgres, for example. Let's say if I go to Docker Hub, so Docker Hub is like GitHub. So in GitHub we have repositories, different repositories, right? So Docker Hub is kind of GitHub for all the Docker images. So here you can search for, like, let's say we are using Postgres database, right? So let's see if I search Postgres. So we have a built-in image for Postgres. So we can use this, but in order to run our fast API application, we have to build or create our own image, right? So for that we are creating this Docker file. So let's take from, so we have to define base image from which we want to create our image. So we are using Python as our base image. Let's use Python 3.9, and let's define our work directory. It will be fast API. So you can name any, you can give any name you want. So this will be like when our image will be created, within that image, and image is nothing but a small mini OS, you can say, like just EC2 instance or any Ubuntu machine. So in that one folder will be created named fast API app in our case. So in that folder, what we can do is we can copy our requirements.txt into our fast API app. So what this will do is, when we build or create a container from this image, so our work directory will be set, and within that work directory, firstly requirement.txt will be copied, and yeah, then we can run a command to install the all the dependencies that we have defined inside our requirement.txt. And after that, what we can do is we can simply copy all of the files. So we have copied only requirement.txt, but we also need to copy all the files within that instance or that image or that container. So let's do that copy star. So what this does is, dot means it take path relative to this Docker file, and it copies all the files in this hierarchy, and copies all of them into fast API app in this work directory. So this is our Docker file. Now let's create one more file which is called as Docker ignore. So the purpose of this file is same as like we have in Git, right? So we have git ignore file. So in order to avoid few files to be so in terms of GitHub, we have git ignore. There we define couple of different files or folders which we want to avoid to check into our repository. So likewise in for Docker, we have Docker ignore file. So let's say, for example, here you can see we have this virtual environment, right? We don't need to copy it inside our container. So we can define those kind of files over here. So we can write venv, right? Now let's say you have this venv somewhere within your your app folder, or let's say anywhere inside your app. So it can be nested anywhere, right? So for that, in order to tell Docker that it can be nested anywhere, you can use // so it will take check for all the paths and check for venv folder within it, and it ignores it. Let's do same for PyCache. So we don't want to copy those folders as well, PyCache and stuff. So yeah, let's do that as well. PyCache files. Let's also ignore if any git files that we have, and yeah, that's it for git ignore. Now let's create a Docker compose file. Okay, so in Docker compose we can define a version. It's optional actually, but it's good if you define it. Then we have a section called services, where we need to define different services that we need to build images or create containers from. So in our case, we'll have two different services. One is for our FastAPI application, and one is for database. And we can also use another service for PgAdmin. So let's say if we want a GUI to check database, so we can do that as well. So let's first create service for database. So I'll call it as Postgres DB. So you can name it anything that you want. So now, as I have showed you, right, we have this image called Postgres, so we can use this image over here. So it will use that as its base image. Now we can also give container name. So like when we spin up the container from this image, so what name you want to have it. So let's give this container name as FastAPI DB. Okay, now there is this flag called restart. So what it does is, so let's say if any issue or anything breaks inside the container, so it tries to restart it, right? So that's why we give this flag restart always. Then we have to export ports, right? So here we can give host port as 5432, and this is container port 5432. So it means that whenever a request comes on the port 5432 in the host, it will redirect it to the container port. Okay. And then we have to provide few environment variables, and you can see those environment variables here inside this image. Like so I'm taking a reference from this this Docker compose file for Postgres. So yeah, there are these environment variables. So we can give Postgres password or Postgres user, Postgres database. So what happens is, basically when we spin up container from this image, so it uses this environment variables and set those. So for example, let's see if I give Postgres DB, and I want my DB to be called as FastAPI DB. Okay, so basically it creates a database called FastAPI DB. So I want Postgres user as admin. Okay, let's keep it as Postgres, and I want password as admin. Okay, so when we run container from this image, from this base image, so it will create a database called FastAPI. The user will be created as Postgres, and password will be admin. Cool. Now okay, so now there comes this concept of volume. So what happens basically is, let's say now in this case you start the container, and your container will be created, and let's say you create users through APIs and stuff, and that data will be stored. But when you exit the container or stop the container or kill it, so all the data will be lost. So you need that data to be persisted somewhere, right, for your development purpose or something. So for that we can give volume. So in volume, what we can say is, in the current directory dot it takes relative path to the Docker file. So I want in this level, I want a folder called, let's say, db data. So a folder will be created over here with the name db data, and inside the container at this particular position it will be synced. So whatever the like data that is created in the database or the related files, that will be persisted in this folder, and inside the container it will be accessed on this path. Okay, now let's create another service for our application. Let's call it as app, right? Let's give a container name to FastAPI container. Okay, now we don't have any image inside in our Docker hub, right, for our FastAPI over here. So we have official images inside Docker hub, or you can search for image. We don't have any image for FastAPI, so because we are building our own custom application, so for that we have created our own Docker file from which we can build image. So we can just give its context as dot. So basically what it does is, inside, with relative to this Docker Compose file, it checks for a Docker file and it builds image from that. Or you can also, instead of this, you can give Docker file as well, which is this Docker file. Yeah, so it will build from that, it will build image from that and use it to spin up the container. So again, let's expose ports. So let's say if request comes on host on 8000, port 8000, because that is the port where our FastAPI application will be running, so it will be redirected to 8000 port inside the Docker container. And I've also used this depends on flag. So what happens is, basically when we use this Docker Compose file to spin up all these services, so what happens is, it might happen that first this container will be created for this service, but at that time the database is not set up, or the container is not set up, so that in that phase, or in that condition, there are chances that it will exit, this container will exit. So if we provide this depends on flag, so it first waits for this container to spin up and then it spin up this container. So that's why we have given the name, and we have provided this name that we have used for this service, PostgreSTP. So yeah, and also, like, we have used this environment file, right, in order to provide the database URI. So here we can also give env file, and this we can give the path of environment file over here, .env. So it will take the values from this. Okay, now also, let's say you all of your code is ready, you're using your code to create CRUD applications, and let's say you've made any changes, so you'll have to do the same process again, build the image and spin up containers and stuff, let's say. But if you want to directly if you change anything over here in our for API structure or in our application, so you want that to be replicated directly or inside your Docker container, so you can use volumes. So here I can provide .:/FastAPI app. So what this does is, basically whatever changes that we made in here, they are immediately reflected inside this our working directory FastAPI app, right? So this is what we have defined over here, right, inside our this Docker container, Docker image. So yeah, and now we need to provide command to execute or start our container, start our FastAPI application, and run the migration. So we can give bash-c. So using this we can run multiple commands. So mainly we have Alembic upgrade head. So this command, so before running our server, we should apply our migrations, right? So that's why we have given this command, because we'll already have these migrations pushed into our Git repository. So that's why we'll not be creating migrations on inside the container. So yeah, and we have this uvcon. You can also give the command which I used, like FastAPI dev and the file name, but it's better if we use this command uvcon app.main. So inside app we have main file, and inside main we have this app. So that path we have given. This is the reload flag. We have given host as 0.0.0.0, so it will be accessible, and port is 8000. Cool. Now let's use one more service called PgAdmin. Let's call it as PgAdmin, and image, let's give image as dpage PgAdmin 4. So you can search for PgAdmin image over here, and yeah, this is the image, dpage PgAdmin 4. So you can use this image. Let's give container name as PgAdmin. yeah, so restart always. Ports, so we've defined that on localhost 5050 this PgAdmin will be accessible, and the container port is 80, and we don't need to have any volume for this. Just we need to provide two environment variables, which is this default email. I guess that is it should be somewhere here. Let me just copy this. Yeah, so these are the environment variables, email and password. This we need to provide in order to log in. So as of now, let me just provide admin@gmail.com and admin. Okay, and depends on PostgreSDB. One more thing, so it might happen that this server takes a bit of time, and even if this runs, there are chances that it might fail. So we can add health check over here. So inside our PostgreSDB service, we can add health check, which is, and here we provide test command. So we can use cmd shell pg is ready -u postgres. So it basically checks if when the database container spins up, it checks like if it is accessible. So we can give interval 5, let's say 10 seconds, timeout as 5 seconds, and retries 3 times. So what we are saying is basically, once this container is running, we are testing using this command whether the Postgres or PG the database is accessible. So we are trying 3 times, the timeout is for 5 seconds, and yeah, interval is 10 seconds. So yeah, so now inside our app, inside depends on, we can do is we can give condition as service healthy. So it basically, this container will not spin up until this database container is up and running and it is accessible. The database is accessible. So once the database is accessible, it means service is healthy, then it will spin up this container. So yeah, and one more thing, now as we have given this environment file inside this app, right? So we have this .env. So here we have to change our host to the container name, right? So we have to change it. We have to provide this database container, because these are the credentials for our database, right? So mostly the host will be this, where this container will be running, database container. Then we have the port 5432, Postgres admin, and our test database. So the database name is, what the database name we have given, let me see, database. Okay, let's just keep it as FastAPI-DB. Okay, cool. So yeah, this should work. So currently, as you can see, we don't have any containers running. We have a couple of images, and let me just clear this volume. Okay, cool. So the first step is we have to use Docker Compose to build our custom image, which is this FastAPI container image. So I'll use Docker Compose and build. So it will hopefully build the image. Yeah, so it should have built the image. Yes, as you can see, this is the image which is just created, and it is named after FastAPI Docker-app. So it uses the directory name FastAPI hyphen docker and hyphen the name of the service. So we have built the image. Now what we can do is we can use docker compose up. So using this command, all of the services that we have defined inside our docker compose YAML file, so all of these services, the containers will be created for all of these services. So and let's say you want to, okay, let's just run it. Here you can see a default network is created, then container is created for FastAPI DB service, which is this for a Postgres DB service, and this is the container name. Then another PgAdmin container is created, which is this is the container name, and then FastAPI container is created for our application, which is this FastAPI container for this app. But I guess there is some issue that port is already in use, so let me just go here. Let me just change the host port. Yeah, so what this means is basically whenever the request will come to 5433 port of host, it will be redirected to 5432 port on the container. So yeah, you can see this FastAPI DB. So the database service is, the container is being created for this service. So I've modified docker compose.yml file. So there was some issue with the database name, so I've just kept database name as fastapi_db. And yeah, also in the .env file, I've modified the db name variable to fastapi_db. So now let's just build it. Docker compose build. Okay, images has been built from the docker file. Now let's just hit docker compose up -d. Okay, so this D is basically it runs the containers in the detached mode. So yeah, let's just go to Docker desktop and see inside this. You can see that FastAPI DB container is running, and you can click over here to check the logs. You can see the PgAdmin service is also ready and FastAPI container is also ready. So all of the containers are up and running. Okay, so now as you can see, this PgAdmin service is running on the host port 5050. So what we can do is we can simply go to localhost 5050, and you can see this this is the GUI for PgAdmin, and the credentials are, we have given these credentials inside docker compose YAML file inside this PgAdmin. So we have email as admin@gmail.com and password is admin. So this is the email, password is admin. So yeah, now once you log in, you need to register the server, where let's give this name as FastAPI database. And now here the host name. So what you can do is you can either give the host name as the container name, which is this FastAPI DB for this database, or you can go to inspect and you can give the IP address as well. So for simplicity, I'll just keep it as FastAPI DB, so it will resolve to that particular IP address automatically. So our username is Postgres and password is admin. So these credentials are inside this service, Postgres DB service. Okay, so let's just connect, and yeah, you can see we are connected to our database. And let's go to FastAPI DB, schemas, tables, and you can see we have user table. So let's just query, select star from users, and as of now we don't have any users. So let's just go to postman and let's just hit this list user API. So So we don't have any user, right? So now this is not any local server. So we are running our fast API server from the Docker. So when we are hitting this URL, which is localhost 8000, so it is, the request comes to, as you can see here inside this app service, this is the host port and this is the container post. So when the request comes here and hits this 8000 port of host, it actually redirects to 8000 port of the container, and there it actually executes. So yeah, let's just create a dummy user over here. Let's name it as test user 1, test user 1 @gmail.com. Let's add a phone number and let's save this. So we have now one user, and now let's try to hit this. So yeah, we got one user. Let's try to create another user. Okay, let's check with the list user. Yeah, we got user. So let's try to get the user with ID 2. Cool, this is also working. Let's try to update user with ID 1. Okay, now we have the name in caps, camel case, and let's check with, currently we had a small case for user 1. So let's check. Okay, this is also updated. Now let's try to delete the user with ID 2. Okay, deleted 200. And let's check with this user. So yeah, all of the APIs are working now. Cool. Okay, so whenever you're doing development, right, so you can just come here inside this Docker desktop, and you can go to this particular container where we have different containers running. So let's say you've done with the development for the day, so you can just simply stop the containers, right? And yeah, you can leave. You don't have to delete them. So let's say you log in the other day, the next day, and you can come here and you can simply start these containers. So firstly you'll have to start a database container because other containers are dependent on it. Then you can start PgAdmin, and then you can start FastAPI container. So yeah, all of the containers are in the running state. And yeah, if you want to check logs at any point in time, so you can come click on this particular container, and you can see there are different sections: log, inspect, execute. Let's say if you want to execute any command over here, you can do that. You can check all the like files that are present. So yeah, I guess that's pretty much it for this video. Okay, so I hope you guys liked it. Thank you so much.